Isosceles and equilateral triangles are interesting triangles. Earlier we saw this same diagram, but we did not really talk too much about what was really special about these three particular triangles. We identified them as right triangle, this one as a right triangle, triangle MLN. And we noticed that we had two equal sides, which is why this triangle is called an isosceles triangle. But you may not have noticed that not only are the two legs the same, they happen to be 4.5 units, but the two angles, the acute angles, are also the same. Likewise, in our pink triangle, triangle NEK, we saw that we had two equal sides, making this an isosceles triangle. But also, it had three acute angles, so we called it an isosceles acute triangle. And you may or may not have noticed that we had two angles that were both 76 degrees. So once again, not only two congruent sides, but two congruent angles. And finally, we had a third triangle here that we identified as an equilateral triangle. And we said because all three angles were 60 degrees, it was an equiangular triangle. And it had three sides that were 9 in length and 360-degree angles, which were acute. So this brings us to something called the base angle theorem. And in order to understand what the base angle theorem is, we have to identify the parts of an isosceles triangle. So an isosceles triangle that has exactly two congruent sides, we call those two sides the legs of the triangle. And we call the angle that is formed by those two legs the vertex angle. And the third remaining side is our base. The two angles that are adjacent to the base are called the base angles. The two angles that touch the base that are adjacent to it, these two angles are called the base angles. So our base angle theorem says that when two sides of a triangle are congruent, then the angles opposite those two sides also have to be congruent. So my two legs are congruent, therefore the side opposite that the angle opposite that congruent side and the angle opposite the other congruent side have to be congruent. If AC is congruent to segment BC, then angle A has to be congruent to angle B. That is the base angle theorem. You have two congruent legs, which forces the base angles to be congruent. The converse of the base angle theorem is the switch of the two. We change the hypothesis with the conclusion. So it says when two angles of a triangle are congruent, then the sides opposite those angles must also be congruent. If angle D is congruent to angle F, then segment EF has to be congruent to segment DE by the converse of the base angle theorem. Get the angles congruent, then the sides are congruent. Which starts us off with our example number 2. And it says, I need to know the distance between A and B. So the distance between A and B can be found by first identifying all three of our angles. A is the point 0, 3. B is the point 4, -2. And C is the point -4, -2. So when we want the distance between A and B, we want to know how much have we moved horizontally versus how much have we moved vertically. So horizontally, we moved between 0 and 4. Distance between 0 and 4 is 4. Vertically, we moved between 3 and -2. The distance between 3 and -2 is 5. Once we have those numbers, we square them, then add them, and take the square root of them. 4 squared plus 5 squared gets me c squared. So the square root of those two, the squares of the sums, is going to get me my distance between those 2 points. 16 plus 25 is 41. Now we need to find the distance between A and C. The distance between A and C, once again, says how much did we move horizontally? From 0 to -4, we moved 4. Distance is always positive. We'll square that 4. Then we ask how far we moved vertically, and once again, the distance between 3 and -2 is 5. So no surprise, 16 plus 25 will once again get us a square root of 41. And lastly, we're going to find the distance between B and C. So we moved only horizontally, not vertically. We moved horizontally 4, and horizontally 4 more, and 4 plus 4 is 8, and we can count a horizontal or vertical movement. So because we have exactly two sides that are equal, we know that this is an isosceles triangle. We can show that they're equal legs by giving a tick mark for each one. And once we realize that it's an isosceles triangle, because we know the angles of a triangle add up to 180 degrees, 180 degrees minus 70 gives us 110 degrees. And those two angles have to be split evenly, like we saw above. So we'll take the 110 degrees and divide it by 2 to get 55 degrees. So the measure of angle B is 55 degrees, and the measure of angle C is 55 degrees. All right, example 3 said, let's find the measure of angle J. Well, we see that we have an angle at L that is 60 degrees, and we see 12 feet for the distance between J and L, and the distance between J and K. Once we realize that we have an isosceles triangle, we can use the base angle theorem to say that if the two sides are 12 feet, then the two angles have to be congruent. And 60 degrees is the same as 60 degrees, so angle K also had to be 60 degrees. 60 plus 60 is 120 degrees. So if we have 180 degrees and we've used 120 of it, our remaining angle has to also be 60 degrees. So the measure of angle J is 60 degrees. Not only is this an isosceles triangle, it is actually an equilateral triangle. Lastly, in example 4, we're finding x and y. So in this image, we see that we have two tick marks. Those tick marks are indicating that segment BC is congruent to segment BA. So if segment BC is congruent to segment BA, we could set those two measurements equal. 6x plus 6 equal to 4y minus 2. However, that won't be very easy to work with because we have two variables. But when we realize that we have a 60-degree angle here at angle A, that is a base angle. It's opposite this equal side, so it's a base angle with angle C. It's just rotated. We're not used to seeing possibly those angles to the side, but those are our base angles of our isosceles triangle. So if angle A is 60 degrees, angle C must be 60 degrees. And that leaves angle B to be 60 degrees. Once again, we're working with an equilateral, equiangular triangle, and that lets us know that all three sides are congruent to one another. Now we can work with the sides that involve y. So we know for y minus 2 has to equal 2y plus 2. If we subtract 2y from both sides, we'll get our letters to the left and have 2y. If we add 2 to both sides, we get another pair of 0 pairs, and 2y becomes 4. Then dividing by 2, y is 2. So we've found half of our answer. It asked us to find x and y. Now that we know that y is 2, we can substitute our 2 in for y, and 2 times 2 plus 2 has to be the distance between A and C. So 4 plus 2 is 6. If the distance between A and C is 6, then the distance between B and C also has to be 6, because it's an equiangular triangle and an equilateral triangle. So 6x minus 6 has to equal 6. When we add 6 to both sides to create a 0 pair, 6x equals 12. Dividing by 6, x also has to be 2.